Hello, thanks for joining another TechStar T3 video session. My name's Craig Longcor. I've been with TechStar since 2006, been in the process control instrumentation field for the past 30 years. Since 2001, TechStar's been your one-stop shop for quality process control instrumentation, analytical equipment, as well as condition and vibration monitoring systems for rotating machinery. Here at TechStar, we're committed to providing best fit application solutions so that safety and reliability is not compromised in any way. In addition, TechStar also supports our partners with field service and user training, as well as custom engineered solutions when necessary. Today, what we want to spend a little time talking about how to achieve safe and reliable level measurements. Matching the level application needs with the best fit measurement technology. As with flow, level measuring techniques are highly varied and use many different technologies. Optical, vibrating or tuning forks, ultrasonics, floats, radar, guided wave radar, and or TDR, conductivity or resistance, also known as RF capacitance, pressure, either differential or static, and of course load cells, which is a direct weight measurement. Choosing a level sensor starts with defining the specific process need within the application constraints. Level measurements are either continuous or point level, also known as discrete. That is, they indicate whatever the level is in the tank, whether it is above or below a specific point. If you need 100 gallons of liquid for a process from a given tank, it may be enough to know that the measure is greater than 100 gallons, but how much greater isn't a concern. Similarly, you may want an alarm if a level has fallen below a specific point before a tank is pumped dry, or a high-level alarm before it overflows. Selecting a measurement approach should begin with an analysis of the process and what information you need, what information you want, and how you want that information transmitted. What are the contents? Measuring a solid has specific challenges since powders and granular products don't always settle. They can coat interior surfaces or cause rat holes near exit points. This can create unreliable readings, depending on the technology. Well-behaved liquids are typically easier to deal with. However, slurries and solid contents can also cause settling issues in liquids. Foam, turbulence, or even dust can deceive reflective measurements, and dielectric characteristics can affect capacitive sensors. How precise of a measurement do you need is another consideration. This usually only affects continuous measurements, but depending on the size of the vessel, very precise measurements are possible. The highest accuracies for volumetric will need pressure and temperature compensation. Is contact with the contents possible? Many methods involve being inside the vessel and in contact with the contents. Some technologies don't require this, however. For example, radiation-based measurements or radar, which do not have contact with the contents. Is it possible to penetrate the tank wall or be inside the tank? Some methods do not need penetration into the tank at all, but if the contents are very sensitive or if the tank is under high pressure, tank penetration could be a concern. If the situation calls for adding measuring capability to an existing tank and there is available process connections, modifications might be needed. How well do you know the interior dimensions? If volume is the goal, all the interior dimensions must be fully quantified, and deductions made for baffles, paddles, heat exchangers, etc. A precise level reading cannot correct for imprecise dimensions. Do you have limited infrastructure? Like most types of process instrumentation, level sensor vendors are always looking for ways to more efficiently use power and reduce electrical consumption. Some approaches are better than others with this respect. Low power consumption generally means that the sensors are more practical to interface with wireless transmitters, and it improves the capabilities in hazardous areas. Most can be triggered intermittently, but the ability to respond quickly and not use a lot of power in the process varies a great deal. Sensors using magnetostrictive technology, for example, have greater potential for such adaptation. Of course, electrical consumption isn't the only piece of the puzzle. All other performance trade-off considerations still apply when examining the application. Matching the level application needs with the best fit measurement technology is key to achieving the most reliable measurement possible. Product specification sheets and sales literature should always be supplemented with in-service experience that TechStar can provide, and we are only a phone call away. Thanks for watching, and I hope you can take the opportunity to view some of the other TechStar training videos. Please reach out to us if there's anything we can do to assist with your measurement needs.